All right, we are going to continue with our composite functions. We're going to write a rule for a composite function, this right here. So that looks like a multiplication symbol. Maybe we didn't have the correct keyboard notation, but what that is, it's an F and then it's actually more of a circle like that. So how we read that is F following G. So F following G of X is how we would say that. That is the same thing as F of G of X. So I just want to make sure you guys know all the ways you might see this. So F following G of X is F of G of X. So we're going to do a composite function of F of G of X. So let's just define, we know G of X function is 2x minus 5. So F of G of X means we're going to do F of 2x minus 5. That's our G of X function. So then we look at our F function. We're going to plug a 2x minus 5 in for any x's. Here's our F function. So right there, for that x, we're going to replace that with a 2x minus 5. So we have the square root of 2x minus 5 plus 7 all underneath that square root. Now, we wanted to simplify this. There's nothing to distribute with this 2x minus 5. I always put parentheses around things that I'm plugging in. So because there's nothing to distribute in, we can kind of ignore the parentheses. We have a square root of, that 2x does not have any like terms, so that's going to stay as a 2x. And then negative 5 plus 7 is plus 2. So F following G of X is equal to 2x, square root of 2x plus 2. All right, so now let's talk about the domain. How do we do a domain of a composite function? So the domain of composite functions is the intersection of the domains of our G function and F following G function. That looks like I just wrote out the word fog. So F following G. All right, so because our G of X function is essentially what is what's on the inside here, we want to know the domain of that because there may be some restrictions. And then when we do our composite function, we want to look at our end result here. What kind of domain restrictions would we have? So the domain of G of X if we look at our G of X function, it's just a 2x minus 5. That's good. So that's going to be all real numbers. No domain restrictions there. But then when we look at the domain of F following G of X, well, we have something underneath a square root. So the square root of 2x plus 2. Can you square root every numbers in existence? No, not if you want to stay in the real number system. So you can't square root negative numbers. So we're going to make sure that the 2x plus 2, the thing underneath the square root, is not negative. So we want it to be greater than or equal to 0. We're going to go ahead and solve this for x because we want to write our domain in terms of x. We have 2x is greater than or equal to negative 2. Divide by both sides by 2 and we get x has to be greater than or equal to a negative 1. So the intersection of all real numbers and x has to be greater than or equal to 1 is just that restriction. X has to be greater than or equal to 1. So let's just tag that on. There's the domain of our composite function. All right, well, let's try another one because these are so fun. We are going to do F following G of X, which is the same thing as F of G of X. So let's start with our G of X function. G of X is 4 minus X. And now we're going to find F of that. So there's our f of g of x. So if we go up to our f function, we're going to plug in a 4 minus x for every x that we see. So our f function is x squared. So we're going to do 4 minus x squared plus x, so plus a 4 minus x, and then plus 2. So if we look at our f function right here, we took this 4 minus x and plugged it in for this x, and then we plugged it in for that x. All right, so to simplify this, we are squaring a binomial right here. So we have to multiply that out off on the side. What is 4 minus x times 4 minus x? We get 16 minus 4x plus x squared if you multiply that out. So I'm going to go ahead and write down the simplified answer. There's a positive x squared minus 8x plus 16. I just kind of wrote it in order. Plus, now this 4 minus x, there's nothing to distribute, so I'm just going to write 4 minus x and then carry down the plus 2. Combine any like terms. We have an x squared. We have a negative 8x and a negative x. That's going to combine to give us a negative 9x. And then we have a positive 16, a positive 4, so 16 plus 4 is 20. Oh, and a positive 2, so plus 22. So f following g of x is equal to x squared minus 9x plus 22. Now let's go through our domain. So our domain is the intersection of g of x. So g of x function, 4 minus x, there's no restrictions there, so all real numbers. And f following g of x, x squared minus 9x plus 22, no restrictions there. So the domain of the composite function is all real numbers. Again, interval notation, negative infinity to infinity. All of these are appropriate ways to write your domain.